Here's a functional equation, and quite a good one at that. Let there be a function f from z to z. Z is a set of integers, such that f of x times f of y equals f of x plus y plus f of x minus y for all xy belonging to integers. If f of 1 equals 3, then f of 7 equals. So let's think about it. Whenever you have a functional equation, and you start with putting in trivial values. So what is f of 0? Let's think about it. So f of 0, let me choose a slightly different color. Let me choose blue. So f of 0, let me just rewrite it. F of 0, what is it? So one way that I can look for it is putting in x equals y equals 0. Then you have f of 0 squared equals 2f of 0. That means f of 0 is equal to 0 or it is equal to 2. What else can we write? So since we know what f of 1 is, let's try putting in y equals 1. So you have f of x times f of 1, that's just 3, is equal to f of x plus 1 plus f of x minus 1. And this is good. Why? Since once we know the first two members of the series, 0 and the first element, you can generate all other elements by just repeatedly plugging it in. So let's think about it, how we can figure out what exactly f of 0 is. So to get f of 0 in this equation, let's try putting in x equals 1. Now what would that mean? That would mean 3 of f1 equals f of 2 plus f of 0. 3 of f of 1 is, well, 9. So this is equal to 9. And f of 0 is equal to 9 minus f2. What is the other way that we can obtain f of 2? One other way that you can think about it is try putting in x equal to 1, y equal to 1. Okay, that's just been done right there. What can we do next? So if we think about it, if we put y equals 0, it gives f of x times f of 0 is equal to 2f of x. So that means f of x times f of 0 minus 2, this has to be equal to 0. Now we cannot say for guarantee that f of x is always equal to 0. In fact, it is not. F of 1 is equal to 3. So that means f of 2 must be equal to 2. So we could have just directly jumped in here and saved us some trouble. But anyways, so f of 0 is equal to 2. And since f of 0 is equal to 2, f of 2 is equal to 9 minus 2, that is equal to 7. Can we generate numbers like this again and again? Oh yes, we can. So f of 0, I'll just write in the numbers right here. 0, 1, 2, 3, 4, 5, 6, 7. We're supposed to find f of 7. Okay. So for 0, the value of f is 2. For 1, it is 3. For 2, it is 7. And notice the generating function that we have. The generating function that we have is f of x plus 1 equals 3 of f of x minus f of x minus 1. So what will the value for 3? The value for 3 will be 3 of 7, that's 21, minus 3. So that's 18. Then 3 times 18, that's 54, minus 7, so 47. Again, 3 times 47 minus 18, so 141 minus 18, that is equal to 123. I suppose I'm not committing any calculation mistakes. And f of 6, so 3 times this, 369, minus 47, this is 322. And then 3 times this, minus this, so 3 times 322 is 966, minus 123, that is 843. So there are many approaches though. This one just came to my mind. So 843.